Thank you very much indeed for that introduction. Cooling is the new heating. It is not my term. I've taken it from the Institute of Energy. I'll talk about that in a second. And the self-denial, to me, and I hope at the end of this talk to you as well, is really that there's a lot of organisation and institutions in New Zealand who are simply not prepared to face up to the facts of cooling is becoming more and more predominant, and we need to do something about it. Yay. So just to cover what I want to talk about. First of all, what do we know about the extent of energy used for cooling buildings in New Zealand? So, what is our problem? Have we got a problem? And then look at the current building codes. Are we actually doing the right thing about the cooling problem? And then I want to look at research into cooling in commercial buildings. I'm going to touch on residential buildings, but really predominantly look at commercial buildings. I'm then going to look at New Zealand institutions and what they contribute or don't contribute to this problem that we have. And then I want to look at why there is no cost incentive to improve energy standards in commercial buildings. This is absolutely key to why things aren't changing. And then finally, look at the new 2021 acceptable solutions for cooling buildings, which just came in December. So, is cooling the future of heating? Was the International Energy Agency's document that was produced almost 2 years ago, which I think is self-evident. It's saying that the climate is getting warmer, that buildings are going to get warmer as well, and if we're to maintain comfort conditions, cooling is become more and more predominant. And the question is to what extent that will be, because obviously in hot countries we already cool most of the time, such as Malaysia. But in countries that are temperate, or indeed in Auckland, which is semi-subtropical, we are getting to the stage where cooling is a significant contribution to the energy consumption of a building. And I don't think we need proof of this, but in New Zealand, 6 of its 8 warmest years occurred after 2013. We are warming up in New Zealand. And of course, this has been recognised, and New Zealand government announced that we are in a climate change emergency. And my big question in my last slide today will be, well, are they responding as if it's an emergency? So what do we know about energy used for cooling buildings in New Zealand? And the answer is very little for both residential and commercial buildings. In many other countries, particularly in the OECD, there will be a breakdown of how much energy is used, for example, for heating, lighting, cooling, across various building types in different sectors. In New Zealand, we simply don't have that data. There's a little bit here, there's a little bit there. So I'm just going to touch on what we do know, and some of it's, and I'll start with residential, although I really want to focus on commercial. So brands did some really good work about 10, 12 years ago, looking into the uptake of heat pumps, because at that time, of course, they were subsidized by the government, so people were taking them up. And they were brought in to try and reduce emissions from wood burning. But of course, when we brought them in, they also had a cooling mode, so people discovered I can cool with them. And so brands looked at them, and one of the interesting things, they said, well, it may be getting warmer, which might reduce our heating load, but it's going to get, but also it will increase our cooling load. But overall, they predicted, our overall energy consumption would increase. It wouldn't balance out, heating balances cooling, it would be an overall increase, which was a really important thing to say that climate change actually can mean more energy. Another little bit of research that was done, this was actually done, looking at award-winning buildings. Unfortunately, can't quite pick up that graph at the end. It's just an interesting study looking at how architecture was impacting on cooling loads in buildings. And what was done here was that all the housing that had won awards for the last 50 years were analysed or modelled in terms of its heating load and its cooling load. And guess what? The heating load, you can't quite see it in the screen because it's masked there. Oh, it's just going to disappear. Yeah.
Or would you prefer this?
That's fine. That's fine. So the heating load was increasing slightly, and that's because the proportion of glazing has been increasing as architects have been putting more and more glass in the building. And it's been going up by about 25% over 50 years. But cooling load has gone up 300%. And the main reason for this, there are several reasons, but the main reason for this is summed up very nicely, oh dear, by this advert. And what this advert says here is for heat pumps, and it's not particularly this company, I'm not getting at this company at all, but this advert says, if it can be designed, we can cool it. And what that does basically is give designers the license to say, I don't have to think about any form of passive cooling, I don't have to shade my building, I don't have to think about the orientation of it, all those important things for cooling, because this little machine that we put in our heat pump can do all that for us. So passive design no longer really important. We just put in energy into there and we can cool it. And for many designers, that's, well, I don't have to worry. A lot of glass facing north, it's going to overheat, doesn't matter because we can cool it. And that is an attitude that I've noticed in many years being in New Zealand, particularly in education. Why worry? You know, what are we talking about? We just stick in air conditioning. So going down to commercial buildings and looking at building codes. Building code, and currently as well, because the new ones don't actually come in for another year, almost a year. You do not have to take account energy used for air conditioning in order to comply with the building codes. Now that's under the prescriptive method. If you go into modeling, yes, you do. But basically, you can get away without even considering cooling in the building codes. And that has been around for almost 30 years now, since 1996. There was an update in 2007 of this particular standard, but it did not change anything technically to do with that. So this standard of saying, well, you don't really have to take account of cooling has been with us for 30 years, which is too long because everything has changed during that time. And just a little note to say that the OECD consider that the building codes in New Zealand are the lowest in the OECD. So not only have we not changed them, we're also, it's not as if they're brilliant, they're actually probably the worst. So we have to do something about that, which is why New Zealand's been looking at that. So what do we know about cooling load of commercial buildings? The brands undertook the building energy end use study, BEES, started just over 10 years ago, lasted for 6 years, and it was by far the largest research project done into understanding the energy profile of New Zealand's non-residential buildings. Unfortunately, from what I can see, I'm sorry to be contentious about this, they really didn't look hard enough into what cooling was the problem. If you want to understand New Zealand's energy profile of non-residential buildings, you look into heating and cooling. They did look into cooling, but I think it was like a dozen buildings or something like that. And what they said was that there was huge variation. I think the top one was something like 85% cooling and the rest heating. But really, given the amount of time that was spent on it and the number of buildings, cooling was never a major issue. And the main recommendation that came out of it was actually not based on actual buildings that they looked at, but on modelling of one building. And that said that you might be able to save about 40% of energy if you looked at both cooling and daylighting. So to me personally, this was an opportunity that was missed, because as far as I know, there's no other study being done like this at all. So that is why earlier on I said, I don't think we know much about cooling of buildings in New Zealand. So if we look at New Zealand institutions, the Green Building Council, of course, has something to say about it. The Green Building Council is, they're voluntary codes, you don't have to follow them. But one of the interesting things is that you get more credits for an air-conditioned building than for a naturally ventilated building. Now, some buildings I can see we have to air condition, and I don't have a problem with that. Hospitals and certain high-rise buildings, you can't just open the windows at the top. But it just seems very unfortunate to me that if you want to get all the stars you possibly can, you effectively have to air condition your building. And I've written about this since 2011, and I really would hope that at some point they would start looking at their criteria and think about how it impacts on climate change. The Property Council, and the Property Council are really important because they advise developers on various things, but one of the things is, of course, rental value. And any developer will want as much rental value as they possibly can out of it. And from what I remember, the Property Council rates buildings A, B, C. I can't remember whether there's a D, and then there's a sort of nothingness. And if you look at the different criteria of it, pretty high up is air conditioning. And the more energy consumed by your air conditioning unit, because they look at it in terms of kilowatt hours per square meter, the higher the grade of your office development, the higher the rent you can pay. So the incentive there is for developers who want a high rent return to put in the biggest air conditioning system they possibly can. And again, I would hope that the Property Council would start saying, hang on, we need to think about the climate, we need to think about energy, although developers probably don't pay the energy bill, the tenant would, but to consider reducing energy and look seriously at how can we reduce air conditioning loads or eliminate air conditioning. And then there's the New Zealand Institute of Architects, whose in 2020's response to building for climate change was, any changes to the building code may further put pressure on building costs. This is an international response by architects. You know, you're going to push the price of buildings up. If you do this, it's going to cost more. The compliance process for buildings that are not standard should be kept simple in order to avoid stifling innovation. The stifling innovation is another thing. In any country where people introduce new standards, you get architects saying, oh, no, we're going to stifle, you know, we're creative people. If you ask us to increase standards, you're going to take away our creativity. Well, as an architect for too many years, I just wondered if, you know, this is a really interesting little comparison here. So in 1920, Mies van der Rohe, famous architect of the modern movement, designed this building. It was all glass. It won the competition. It didn't actually get built, but it won the competition for mechanical lifts. It was, for all intents and purposes, the point at which modern architecture for office buildings started. And that was in 1920. And here we have Commercial Bay, 2020, 100 years later. From an environmental point of view, there is no difference between these two. All glass, single glazing, fully air conditioned. Same, 100 years later. I don't think we're stifling creative ideas. This shows it's bracing on the outside, that has its bracing on the inside. But environmentally, they are effectively the same. That in 100 years, we have learned very few lessons into it at all. And Mies van der Rohe, of course, was famous for saying, less is more. So, you know, he's really minimalized everything in the building. It's just a glass facade, which is what we've got there. But when you think of less is more, in terms of energy and climate, it's a bad joke, because less proper envelope construction, shading, consideration to the environment means more energy consumption. And we really need to get away from the modern movement and look towards the climate as it stands at the moment. Now, you might say, well, what's the problem? We just go on cooling. It's just going to cost us a bit more money. And, you know, that's between us and our tenants in commercial buildings, and they're prepared to pay for it. So why should we, in any form, regulate it or try and improve building performance? We just pay for it. Well, it's not as simple as that. So this graph here, and I'm totally indebted to Jeff Bertram at Victoria University, who has done some wonderful work on this. Really recommend you looking at his work. So this is electricity costs in real terms, not in actual terms, of course. Everybody's been paying more as time goes on, but if you take inflation into account. So in here are two vertical lines, and they come roughly here between 1986 and 2000, and that was roughly the time, the transition to privatizing the electricity supply industry. So during this time, it was state-owned. During this time, it transitioned. And then during this time, it is now effectively private companies that run it. The blue line shows the price of electricity for commercial buildings, for commercial use. And what we see is that it was quite high up here. And then as privatization came in, it went down and down and down here. Residential was low, and they've crossed over in the middle. So at this point in time here, when privatization just started, people were saying, oh, it's crazy. You know, commercial people are paying more than residential. It should be balanced up. And so, yep, sure, it balanced up. And at this time, roughly commercial and residential electricity prices were the same. And one would have thought then on that argument, it would stay roughly similar. But no, it didn't. Residential building electricity prices went up and up and up. And if you look at this is about 30 cents per kilowatt hour here. It only goes up to 2018 from below 15. So that's effectively doubled over the period on this graph, whereas in commercial prices of electricity have gone down and down and down. The important thing about this is that this difference now is really quite great. So if you say, what is the incentive of reducing the energy demand in commercial buildings in terms of cost? There's no incentive, because basically prices have been going down in real terms. Why would you want to improve the performance of your building if the cost of electricity is going down? It doesn't make sense. So we're not going to change it. But what's happened is that
distance offering and
the residential users have effectively been subsidizing commercial users. It's not a true subsidy in the terms of the word I'm using, not an economist. But whilst these prices of electricity have gone down, so if the cooling of your building is going down at the expense of people heating their homes. And bear in mind, about 25% of these homes now are considered to be in fuel poverty. So it's not a straightforward case of saying, in commercial buildings, we'll pay the bill, don't worry about it, because you're not paying the bill. These guys are paying it for you to a large extent, which starts to separate out New Zealand. So let's jump now to only a few months ago. So in December 2021, exactly a year after announcing a climate emergency, and 25 years plus since the thermal envelope standards were reviewed, the New Zealand government introduced the new acceptable solutions for energy efficiency in commercial buildings. And for cooling, if you look through it, it says here, requirements to account for heat gains from solar radiation, in other words, cooling, are satisfied by complying with the requirements for thermal resistance. What it's saying is, if you do all these things to reduce the heat loss from your building, so improve R values, for example, then you comply with the cooling load. And there's some partial sense in it, but most of it doesn't make any sense. So the partial sense is the cooling load of a building, if you increase the R values of walls or roofs, it has very, very little effect on your cooling load unless you're in an uninsulated industrial shed. But for most commercial buildings, they're already reasonably well insulated. So when the sun hits the walls or the roof, it doesn't matter if you increase the insulation standards, it would have very little impact on cooling. If you put in double glazing instead of single glazing, which is probably going to be the result, but we'll have to see of this regulation, yes, you will reduce the cooling load and the heat. But the most important thing, if you are looking at reducing heating load, you may want to look at using passive solar energy. So you would orientate your building in such a way that in the winter months, you would make use of the beneficial heat gains from the sun. The problem is with cooling, you want exactly the opposite, because in the summertime, you do not want the sun directly coming through. You want to orientate your building and shade your building in such a way that you reduce your cooling. So to say that you satisfy the standards for cooling by satisfying the standards for heating is completely wrong. And so for me, we have once again in New Zealand, self-denial, shoot yourself in the foot, missed this opportunity. So again, there is no requirement to put any form of shading or consider orientation. And to me, I find that a national disgrace, given that we are in climate change emergency. That is not the sort of response we need from architecture. Thank you very much indeed.